Hi, today I'll be talking about the utility jar, how to use the utility jar across multiple microservices. Have you ever faced a scenario like you are going to develop a microservices using a microservice based architecture? Then you need to use a common functionality like a calendar, using a calendar, date, and also some common logs, and you want to consolidate some common functionalities, common operations into single service, and how to make that as a utility jar, right? You can make that a jar. So pulling out all the common functionality, common features into separate service and make that as a jar, and use that jar as a common utility jar across multiple microservices. So this is one of the architectural style of using features in multiple microservices. So what we have to do here, we need to package the utility code as a separate library project and manage it as a dependency using a build automation tool like Maven, Gradle, Ant, whatever it is. So how we are going to create this utility file, common shared utility jar as part of the project? First what we have to do, we need to create a separate common utils project, and this project should contain only shared code. As I told you, it can contain DTOs, data transfer objects, exception handling related code, logging related code, configurations, helper functions, constants, or any code. I mean, that is very common to all other all other microservices, right? So for example, I'm telling you, you are creating a banking application, and you want to you need a common features like logging, exception handling. Okay, these features can be these details can be used from common library, right? You don't need to include exception handling classes, all the related source classes in each and every microservices, because if you do that, you are reusing the code, you are replicating the code. Instead of reusing it, you are replicating the code in each and every service, that may result in excess code size of the project. So to avoid that, we need to create a common utility jar project, and in which we have to place all these common related code snippets, common code, shared code, and after that we have to build the project. So that is when the second point it is mentioned clear here. We can see here, ensure this project is a standard Java project, not a Spring Boot Java application, to avoid unnecessary dependencies and conflicts in consuming the microservice. So we are creating a standard Java project because we just want to use the just a common code, right? And we are not going to create a separate Spring Boot project. So if we create it will unnecessarily download the duplicate, it may result in duplicate starter conflict, dependency conflicts. So that is why we need to avoid it as a Spring Boot project. Instead we create a Java project. That is what it is mentioned here. And we are going to create a Maven project. Inside the pom.xml file, we need to package the type should be a jar file. Packaging tag here, the significance of the packaging tag is, you can mention it as a jar, or you can also mention it as a war file. You can also mention it as a ER. There are three types of packaging scenarios are there. If you mention it as a jar, it is just a jar file. It is just a bunch of Java class files, and you are just making it as a jar. If it is a war file, means web application archive. Web application related archive means you will have some UI related code also in that code project. Hence you need to package that code as a war file, because you need to deploy that application in a web application server. Okay, you're getting my point, right? You cannot deploy the jar file in web application server. You need to make it as a web war file. So if you are creating an enterprise application, you need to package that application as a ER file. enterprise application, right? Enterprise archive. So that way the packaging, there are three types of packaging. You can package that, package your code, source code, into three types of packages depending on the application type, whether it is a standalone Java project, or whether it is a web application project, whether it is a enterprise application. Means enterprise application, it is a complex project. Okay, it involves both source code, front end, back, middle layer, back end. So it involves everything, right? It also involves data sources, data source configurations in server. So that complete full-fledged application, we generally package that application as enterprise application, which is why we can make it as a ER file. So that is one thing we need to observe. And now we have this, we are packaging it as a jar, right? Now what we have to do, second step, build and publish the jar. Okay, you need to clean the project. You need to install the project. Okay, generally it will generate a jar file in artifact, right? You have to publish the jar file to a shared artifact repository like Nexus or Artifactory. I'll explain you what is Nexus. Nexus is nothing but a remote repository, just like a GitHub. You already aware of the GitHub, right? Git repository. Same way, Nexus is also one of the server where when you upload these jar files, it will publish all these. It will upload the jars to Nexus server. What happens here, when we use this Nexus, whenever we are building the application, the Maven, it first looks for the jar in Nexus repository. Okay, Nexus is like a private repository. It is a proprietary to company, so that way we can actually register for the Nexus, and we can save only our company related jar files, dependencies we can actually upload into the Nexus. Public repository is also there. Most of the projects in real time, they don't directly mention the central repository, public repository in the POM file. They don't mention it. So companies' compliances and companies' policies, rules, they are against the accessing the dependencies directly from the public repository like GitHub or anything. Maven central repository, they don't allow it. Only for doing a POCs, proof of concepts, or some simple projects, for they'll actually point to the Maven repository, they'll use that. For the actual scenario, they will only use the internal private repository, which is called a Nexus. They'll use the Nexus server. They build they create their own repository, private repository. Then they'll publish all the jar files, all the dependencies required for a project into the Nexus repository, and they'll point this Nexus repository in the pom.xml file. Getting my point, right? So this is how in real time we are going to use the Nexus repository, private repository, basically Nexus server. Okay, so some of the projects we can also configure in such a way, like in case if the jar file dependency is not found in the Nexus repository, it will go to the Maven central repository. It will download from there. But most of the cases, all the projects, they'll use the private repository. They'll download the dependencies from the private repository itself. So you see, once your jar is published to the Nexus, what you have to do, you have to specify the jar name, a group ID, artifact ID, the version name in other microservices like this. So when you specify like this, it will directly download that into your microservice, right? It will download it. So you can also manage the versions and update when common utility code needs changes, update the library project, increment its version number, build and publish the new version. Microservices can then independently choose when to adapt a new version by adapting the dependency version. Okay, that way you can do this. So basically you can do this way. There is another way also. If there any utility code is there, you can actually create a separate utility class and consume that utility class wherever it is required. Utility class means just calculating some credit points. For example, you see in banking system, you want to calculate the credit point based on the transaction amount. So this is common for all the microservices. Then what we have to do, you have to create a separate utility microservice. You cannot include this logic in each and every microservice, right? As per the standards of the coding. So that way you can do it, and it would be so helpful. I hope you understood how you can use this common code across all multiple services in microservices architecture. Thank you for listening. Thank you all.